here, for example, she'll say yes. Okay. I don't know how exactly we're supposed to know that. But certainly, for example, Professor Jacob's squirrels, she studies squirrel foraging behavior, they seem to know that nuts are hidden in a particular part of a particular tree. That's a declarative memory, at least expressed in that form, right? They can say, well, it's really procedural. What they do is they know how to get nuts, right? I don't want to have that. I don't want to have that particular fight. Certainly, non-human animals seem to know other kinds of facts. They recognize individual people, for example. So you want to think about that as a declarative memory. And even crows will recognize individual humans that they have contact with. So if I said I recognize you from class or something like that, we'd have to call that a declarative memory. So you got to give it to crows. Whether they have whole autobiographies and think of themselves as survivors of the Titanic and hippies that touch debutantes and things like that, probably not. But I think Professor Jacobs would say, as long as you got a hippocampus, or something remotely resembling a hippocampus, you're going to have at least something remotely resembling declarative memory. Okay? All right, so let's kind of see what goes on here. So again, just to make the distinction, for semantic memory, we're really talking about more or less abstract context-free memory. It's true. It's not true at a particular time or a particular place. And so knowledge about objects, knowledge about words, and categorical knowledge about what vehicles are and what hair is and all that knowledge would want to be classified as semantic memory. Okay, so again, just to repeat what I said in response to the question, it's probably the case that all our semantic knowledge begins with particular episodes, and then the episodic context fades away or gets blurred or something by virtue of kind of accumulation. But it's also the case that episodic memory is formed against the background of semantic knowledge. If you see something going on the street, you can't recognize that as a hippie touching a debutante unless you already know what a hippie is and what a debutante is and the difference between touching and hitting and kissing and stroking and all the other things we can do with bodily contact, which is why semantic knowledge really forms the cognitive basis, the knowledge base for perception. Okay, so just to review the bidding, as far as social cognition is concerned, we've got two types of memory, declarative and procedural. Semantic memory, as far as semantic memory is concerned, usually when a social psychologist talks about the semantic memory, they're talking about something that we call implicit personality theory. That is the kind of abstract theory of people that each of us carries around in our heads and that we use to organize our social intercourse. The episodic memory, as I said before, is autobiographical memory. On the procedural side, and we're not going to talk about this more than just this slide, you've got a bunch of motor skills. How to make eye contact when you're talking to somebody, okay? How tightly to grip somebody's hand when you shake it. That's a motor skill. If you've got a hand that's too limp or a grip that's too firm, you got to think about that. Display rules, whether you'll allow people to see emotional expressions on your face, interpersonal distance, whether you, in particular interaction, how close you can be to the person. And then we have cognitive rules, like the rules that we use to form impressions, as in the Asch impression formation paradigm. Or, for example, we might have cognitive rules about self-regulation. When you're feeling anxious, there are things you can do cognitively that will reduce your state of fearfulness. Those would all be pieces of knowledge, procedural knowledge, that are stored in memory. Yeah. Yes, we're talking about a phenomenon known as childhood amnesia. Most adults don't have very clear memories from before they're about 3 to 5 years old. Sometimes it's more extensive than that. And that's why that is the case is a continuing puzzle. There's another senior honors thesis for somebody. But yet one of the reasons certainly is that a young child doesn't necessarily have the cognitive background that it needs to make sense of the world. Okay, so a little kid walking down the street and seeing a hippie touch a debutante, she doesn't know from hippie, right? So that's something that's probably not going to make much of an impression on her. But there are other factors involved as well. For example, for an episodic memory to be formed, you have to have you have to be able to locate that event in time and place and mark it as a discrete episode. And young kids are not necessarily exposed to an environment in which one day is different from another, or whatever. When you get to school, then Monday's different from Sunday. The afternoon's different from the morning, and all that in a way that's just not true when you're just a little kid running around the house before school. So it's entirely possible that one reason why people begin to acquire autobiographical memories around the age of 5 or so is that it's around the age of 5 that the environment provides them with the kind of information they need to mark out one event is different from another. So it's complicated, right? Almost everything in psychology that's interesting is complicated. So there are at least those two factors: the lack of a cognitive base, knowledge base, and the lack of these episodic markers in the environment. Okay, so let's now look at how we know some of these things about how we represent people in memory. Most of this research is based on an experimental paradigm known as the person memory paradigm, which is a variant on the Asch impression formation paradigm that I discussed a couple of lectures ago. And what we're doing here is we're studying how somebody acquires knowledge about another person. And so what we might do is simply arrange a list of sentences that will say things like, John gave a present to Lucy, John rescued the kitten, John is a professor, or whatever, and ask the subjects to study this, that kind of information, in much the same way that in a regular memory experiment, you might be asked to study a list of words or a list of sentences, except in this case, the sentences describe a particular person. And later on, you're going to be asked to remember that information about that person in the form of some kind of test. Okay, so again, the idea here is that memory about people can be studied with the same basic techniques that we use to study memory about things in general. And it turns out that, just to kind of connect the work on by Asch to this work, it turns out that if you engage in impression formation, if I say, John gave a present to Lucy, John rescued the kitten, John is a professor, and I ask you to form an impression of what John is like, you're going to remember those individual facts about John a lot better than if I simply ask you to memorize them. So now we've got a question of what do person memories look like? In terms of memory theory, how is our knowledge about a particular person represented in the mind? And in general, we think about these things, again, just as with the hippie touch the debutante, in terms of some kind of associative structure. So what we've got here is a node that represents this person, in the same way we might have a node that represents hippies and a debutante or whatever, and then this node is linked to factual knowledge about that person. The example here is this person named James Bartlett. That's what he looks like. James Bartlett is a professor at the University of Texas, Dallas. He's a friend to lots of memory researchers, and because he's got his name refers to both William James and Sir Frederick Bartlett, a famous memory researcher, many of us use James Bartlett as a target in these kinds of lectures. Okay, so you got this guy, James Bartlett, so that's his name, and suppose that I tell you James Bartlett is kind, and James Bartlett rescued the kitten, and James Bartlett is thoughtless, and James Bartlett caused the accident. That's what you know about James Bartlett. This kind of information is now encoded in memory. So from a theoretical point of view, in terms of associative network theories of memory, our knowledge about James Bartlett is going to look something like that. Okay, so now let's look at how individuals are represented in memory in a little bit more complicated way. This is work by John Anderson at Carnegie Mellon University and Reed Hasty, who's now at University of Chicago. And imagine for a second that first you learn a set of facts about two individuals, James Bartlett and the lawyer. First you learn James Bartlett rescued the kitten, then James Bartlett adopted the child, then you learn that the lawyer caused the accident, and you learn that the lawyer cursed the salesgirl. Okay, so that's two facts about each of two people. Okay, and then I tell you, James Bartlett is the lawyer. Okay, so now that I've told you James Bartlett is the lawyer, what do you know about James Bartlett that you didn't know before? Okay, you know that he caused the accident, and you know that he cursed the salesgirl. What do you know about the lawyer that you didn't know before? You know that the lawyer rescued the kitten, and you know that the lawyer adopted the child. How do those two sets of facts, two facts about James Bartlett, two facts about the lawyer, get encoded in memory? Well, okay, it turns out in the first place that these facts do get encoded in memory. And the second thing is that once you learn that James Bartlett is the lawyer, it's possible for you to answer correctly a question like, did James Bartlett cause the accident? By connecting what you know about James Bartlett to what you know about the lawyer, okay? Now, there are lots of different ways you could do this, okay? But it turns out that we do it in a particular way that's really quite interesting. This experiment makes use of a phenomenon in memory called the fan effect, which was studied by John Anderson, in which he performed an experiment very much like the one I just described. The subjects had to study sets of sentences like the doctor is in the bank, the fireman is in the park, the lawyer is in the church, and the lawyer is in the park. Notice that there's one fact about the doctor and one fact about the bank. The fireman is in the park, that's one fact about the fireman, but there are two facts about the park. And then the lawyer's in the church, the lawyer's in the park. That's two facts about the lawyer, and so on. So what happens is, in this experiment, the subjects are asked to take these sentences and memorize them until they can recite them perfectly. Okay, it's a kind of long, drawn-out process. And then they're given a recognition test in which they're presented with study targets, like the doctor is in the bank, target sentences that they actually did memorize, and then other kinds of lures, like the doctor is in the park, which they actually didn't see. What's interesting about this is that the time it takes to answer a question is determined by the number of facts that you know about the object. So, for example, if you know one fact about a target, the lawyer, for example, it takes you less time to answer a question than if you know 3 facts. If you know one fact about a location, like the park or the bank, it takes you less time to answer the question than if you know 3 facts, and so on and so forth. This is what's known as the fan effect. It's kind of a paradox in knowledge. The more you know about a subject, the more time it takes you to answer any particular question about the subject. Now, look at the response latencies here. We're talking about fractions of seconds, but that's why we do these kinds of experiments. These are objectively small effects that reveal important underlying processes. So if you've got one fact about a doctor and 3 facts about a lawyer, it's going to take you longer to answer a question about the lawyer than it will if you're answering a question about the doctor. That's the fan effect. Okay. So and again, you've got one fact about the doctor, he's in the park. One fact about the fireman, he's in the park. Doctor's in the bank, fireman's in the park. 2 facts about the lawyer, and so on. Okay. So now let's go back to our James Bartlett example. We know that James Bartlett rescued the kitten, and we know that James Bartlett adopted the child. We know that the lawyer cursed the salesgirl, and we know that the lawyer caused the accident. Now we learn that James Bartlett is the lawyer. Okay, and what happens is you can represent this knowledge in 2 different ways, at least. One is with a single representation. You've got this single node representing this individual named James Bartlett, who is a lawyer, who rescued the kitten and adopted the child and cursed the salesgirl and caused the accident, right? Or you can have what's known as a link representation, where you've got this node representing James Bartlett, who rescued the kitten and adopted the child, and now you've got a new link from the node representing James Bartlett to the node representing the lawyer, who cursed the salesgirl and caused the accident. We can distinguish between these 2 forms of representation by the time it takes a person to answer the question about James Bartlett or about the lawyer. In this representation, if I ask you, did James Bartlett cause the accident, it should take you no longer to answer that question than if I ask you, did James Bartlett adopt a child, because there's only one link between the node representing James Bartlett and the node representing the fact that somebody caused an accident. If, in the link representation, if I ask you, did James Bartlett curse the salesgirl, it's going to take you longer to answer that question than if I ask you, did James Bartlett rescue the kitten, because you've got to get through more associative links. Okay, that's the logic of this experiment. And it turns out that when you have to make an inference, it takes you longer to answer the question than if you don't have to make the inference. Okay, that tells you that when you learn something about James Bartlett, you learn some things about the lawyer, and then you learn that the one refers to the other. You establish a new link between those 2 representations. You don't just glom them onto each other. You establish a link between the 2 representations, which is why it takes you longer to make these inferences than if you don't have to make the inferences. Now, if I vary the experiment and I tell you at the outset, I'm going to tell you some facts about James Bartlett, and I'm going to tell you some facts about this lawyer, and what I want you to bear in mind is James Bartlett is the lawyer. Okay? If I do that at the beginning of the experiment, the fan effect just pretty much disappears. That's not a significant difference anymore. So it all depends on whether you learn the identity of the lawyer after you've established these facts, after you've learned these facts, or before you've learned the facts. So here we have a basic problem in how we represent knowledge about people, and apparently a solution for it. We have a node representing a person, somebody known to us as James Bartlett, for example, somebody known to us as a lawyer. We have nodes representing facts about the person, his behaviors, his experiences, so that's episodic kind of knowledge, his traits, his attitudes, semantic knowledge about the person, and then we have associative links that connect the node representing the person to the nodes representing each of these kinds of facts. Okay, so that's basically how it works. If the reference is known at the outset, the reference, James Bartlett is the lawyer, is just treated as if it were another fact. Okay? But if the reference is learned later, then you have to establish a new link to get you from the node representing James Bartlett to the node representing the lawyer. I introduce this method to you in this way because we're going to use this kind of methodology to figure out how other kinds of knowledge about people other kinds of knowledge are represented in memory. We're going to use variance on this kind of reaction time paradigm, sometimes using priming techniques, to figure out exactly how this knowledge acquired through perception, acquired through experience, is represented in memory. Quick question. Well, it might not be that easy to change your impression precisely because you've got to establish these new links. Okay. But it turns out that by the time this is over, okay, these subjects know as well as you know the presidents of the United States or the capitals of the states. These people know what James Bartlett did and what the lawyer did and all of that. It should be a fairly simple matter for them to make the translation. That everything I know about the lawyer, I also know about James Bartlett. Everything I know about James Bartlett, I also know about the lawyer. It still takes them more time to answer questions about the lawyer's activity than it takes to answer questions about James Bartlett's activity. And because it takes more time, we know that these two representations have been associated with each other. By the way, it works in the other direction as well. If I say, did the lawyer rescue the kitten? They'll answer yes. But it'll take them longer to do that because they have to traverse this mediating link. So this is what's known as the problem of individuation and reference in memory. How is knowledge about an individual represented in memory, and how are we able to make statements of reference that get us from knowledge about a person known in one respect to a person known in another respect? Okay, that's enough of this. Have a good weekend. Remember, there's no class on Monday. It's President's Day. I'll see you next Wednesday.